Have you ever stopped to think about volcanoes? I mean, really think about them. How can one be this gentle, beautiful force that literally builds paradise islands, while another is a straight-up, city-destroying monster? It's a fantastic question, and to get to the bottom of it, we gotta go deep, right into the Earth's fiery heart.
Okay, let's put some names to this. You've got Hawaii, right? It's basically a postcard from a volcano. Gentle lava flows, creating new land, it's a builder. Then you've got Mount Vesuvius, a name that still sends a shiver down your spine. It didn't build, it buried. It was a killer. They're both volcanoes, so what in the world gives?
Well, the secret, it turns out, isn't about how big the mountain is. It's not about the outside at all. It's all about what's on the inside, the molten rock that erupts. The answer is hidden in the, get this, the personality of its lava.
So let's dive into that. This is really a tale of two lavas. And understanding them means understanding the one secret ingredient that shapes our entire world.
And that secret ingredient is silica. Yep, silica. The best way to think about it is like you're mixing flour into water. If you have just a little bit of silica, your lava is runny and fluid. It flows really easily. We call that basic or basaltic lava. But if you pack it with silica, it gets super thick, sticky, and viscous. That's acidic or rhyolitic lava. And this one little difference, trust me, it changes absolutely everything.
So here's how that silica content creates a full-on personality profile for our lava. The runny, low silica stuff, it's super hot, and because it's so fluid, any gas inside can just bubble out, no problem. That gives you those nice, quiet, effusive eruptions. But the thick, high silica stuff, oh man, it's a bit cooler, and that sticky texture traps all the gas inside. It's like shaking a champagne bottle with the cork jammed in tight. The pressure builds and builds and builds until, boom! You get a violent, explosive eruption.
Okay, so we've talked about what happens when magma erupts. But what if it doesn't? What if its journey gets cut short before it ever sees the light of day? Well, that's when it creates this incredible, hidden world of rock right under our feet. You see, sometimes magma just gets stuck. Instead of blowing its top, it gets trapped deep within the crust. And down there, insulated by all that rock, it cools down really, really slowly. As it solidifies, it forms what geologists call intrusive landforms. It's like a secret architecture, a hidden stone skeleton inside the Earth. So one of the most common shapes you'll find is something called a sill. The best way to picture it is to imagine the magma forcing its way between existing layers of rock, kind of like you're sliding your hand between the pages of a thick book. It creates this long horizontal sheet of cooled magma.
Now, if a sill goes between the layers, a dike does the exact opposite. It cuts straight across them. It's a vertical, wall-like slab of rock where magma has sliced through the existing layers, often following a pre-existing crack or fracture, almost like a highway heading for the surface.
Really, the best way to wrap your head around all this is to think of it as a giant underground plumbing system. The dikes and sills, those are the pipes. Then you have things like laccoliths, which are these dome-shaped blobs that push the rock above them upwards. And the batholiths? Oh, the batholiths are the grand finale. These are the massive, solidified cores of the ancient magma chambers themselves. They're the heart of a volcano that's long gone.
All right, enough about the magma that gets stuck. What about the magma that makes it? The magma that breaks free? Well, that's when it stops being architecture and starts being art. It becomes one of nature's greatest sculptors, creating these incredible sculptures of pure fire. And this is where we see that lava personality directly shape the world above ground. Remember our runny, low silica lava? It flows for miles, building up these huge, broad volcanoes with gentle slopes. We call them shield volcanoes. And the sticky, high silica stuff, it doesn't flow far. It explodes, building up steep, symmetrical cones layer by layer with lava and ash. Those are your classic composite volcanoes.
And right here, we can finally solve the mystery from the beginning. Hawaii's Mauna Loa is a perfect example of a shield volcano, a gentle giant built from countless flows of runny lava. Mount Fuji in Japan, that's your picture-perfect, steep-sided composite volcano. And Mount Vesuvius, it's a composite volcano too, and it's built from that thick, sticky, gas-trapping magma, which is exactly what makes it so explosive and so dangerous.
But hold on, not every eruption is about building a pointy mountain. Sometimes the lava doesn't come from a single vent at all. Instead, it just oozes out of these long, massive cracks in the Earth's crust. We call these fissure eruptions. And when you have these fissures pouring out unbelievable amounts of that runny, basaltic lava, not for a day, but for millions of years, they don't build a mountain,
They build a plateau. They literally flood the landscape, burying everything and creating these immense, flat-topped features. Just look at the Deccan Traps in India. We're talking about an area covering 500,000 square kilometers. It's just staggering.
You know, for all the drama of an eruption, the most spectacular event in a volcano's life isn't building itself up. It's tearing itself down. This is how the largest volcanic depressions on Earth are born.
So how you get something like the famous Crater Lake in Oregon? These massive bowls are called calderas, and a lot of people think they're just really big craters from a really big explosion. But that's not it at all. The real story is so much more dramatic.
See, a caldera isn't formed by blowing up, it's formed by collapsing in. Here's how it works. First, you have a massive eruption that completely empties the magma chamber sitting underneath the volcano. Now, with all that support gone, the mountain is basically hollow. It can't hold up its own weight anymore. So, the entire peak just collapses downward into that empty space, leaving this gigantic basin. And over time, that basin can fill with water, and boom, you have a place like Crater Lake.
And all of this brings us to a final really important point. Volcanoes are, well, they're a profound double-edged sword for our planet. They represent both incredible danger and incredible reward.
Let's talk about the hazards first, because they are absolutely terrifying. We're talking about pyroclastic flows, these superheated clouds of gas and rock moving faster than a race car. You have ashfall that can smother entire cities and ruin agriculture for decades. And a really, really big eruption can pump so much ash into the atmosphere that it blocks the sun and triggers a global cooling event, a volcanic winter. But, and this is the great paradox, for all that destructive power, volcanoes are also creators. That weathered volcanic rock, it makes some of the most fertile farmland on Earth. They bring valuable minerals like gold and copper closer to the surface. They give us clean geothermal energy, and of course, they create some of the most breathtaking landscapes you will ever see. It's wild, but civilizations have always been drawn to volcanoes, often for the very life and resources they provide.
So, at the end of the day, volcanoes are both architects and executioners. They build our world while also holding the power to threaten it. And that leaves us with a really profound question, doesn't it? How do we live alongside a force of nature that is so powerful, so unpredictable, and so absolutely essential to the planet we call home?